I have 7 years. Now our analyzer was exported to 39 countries, different kind of application: biogas, automobile gas, gasifier, and flue gas, and so on, like that. And for medical gas application. How to use that? This one.
The arrow keys don't work.
Okay, now here is our new company here. At the beginning we have nothing, we just have some idea. Now after 7 years, now we have industry here. It's about 20,000 square meters for the land and the building also. So I told you about something about Cubic. So in Cubic, we have developed 3 kinds of technology. One is the NDIR, and another one is the MEMS-based TCD technology, and the third one is the TCD electric chemical detector. This kind of technology we just buy from Japan because it's some cheap just for oxygen. So in our whole gas analyzer, the produced gas analyzer, this is the 2 kind of main technology in the gas analyzer. NDIR in fact is a traditional way for analysis of the CO, CO2, CH4, SO2, NO, and so on. The principle is very simple, that different kind of gas have different kind of wavelengths for absorption. For example, for CH4, just about 3.3 UN. For CO, generally 4.2. For CO2, for CO 4.64. And CH4 also has another absorption peak where in other area. So firstly, for the gasifier, we should analyze the CO and the CO2. It seems very easy, but in fact, not so easy. At the beginning, we developed this kind of analyzer. I think it's very easy, and shipped to the university in China who do this kind of research in the university. He found some many problem. It's some different with the GC. He told me why. I don't know. At that time, after 7 years, after 1 year, I think after 1 to 2 years, I found that there's some problem that I had to test different kind of the cylinder gas. I found the problem. The problem is that here, yes, CO and the CO2 is different in the peak, but in sometimes it kiss each other. Here, it's like the channels that touch each other. So here, if the peak of the peak wave is you choose is some different. Near that, they have some cost sensitivity. CO has some talking to the CO2, and CO2 also has some cross talking to the CO. This is some problem. So the selection of the filter for that detector is very, very important. For this kind of for gasifier and processed gas, the produced gas, we use this kind of filter. So filter selection is very, very important. So if you buy a generally NDIR CO and CO2 bench, you can use that. In fact, no. Sometimes the problem. This is the reason of the cross sensitivity. So this is our one experience how to use the different kind of CO and the CO2 sensor. Okay. After solve the problem with CO and CO2, The second problem is the stage 4. The difference of the stage 4 in different kind of gas is that in produced gas, in gasifier and the pyrolysis gas, inside this of gas, besides the stage 4, they have another kind of hydrocarbon, the C2, C3, C2H4, C2H6, and so on, C3H6, and so on. This kind of gas have also cross-sensitive to metal. How to analyze that? You see that this is the ethanol, C2. This is the C2. This one is the methanol. You can see that the C2 and the C3 have the series cross-docking to the methanol. So if there are some, especially for the biochar process, the C2 plus is more than 2%. At this level, stage 4 maybe sometimes more than 100%. In fact, just maybe 20%. It takes 100%. So stage 4 in this situation is some difficult to analyze it. So for how to get the stage 4 reading? So this I found that in fact yes, C2 plus have a series cross-talking to stage 4, but I don't want to analyze this peak. So I use another one. Here is the cross-sensitive, you know that. Here is the methanol. Here you see just 1%, the decay is 10%. So if there are 2% of the C plus, maybe 20% methanol disappear here. So it's totally wrong for the stage 4. So we should choose another filter for this stage 4. Here we found the stage 4. Here the main peak for absorption, but the stage 4 also have another absorption peak here. Here have no cross-sensitive of the C2 plus. So we choose this kind of filter for stage 4. This kind of filter for stage 4. So this is no cross-sensitive, or less cross-sensitive to the C plus. This is the reason why we can analyze the stage 4 in different kind of the hydrocarbon, especially for the biochar process, charcoal process. This is our testing of the different kind of the gas. Stage 4, 100%. You see that is 100%. C2 here no cross-sensitive to stage 4. C3 have very less. C4 also very less. So stage 4 reading is perfect. So it's very nice for the for gasifier or for charcoal process, biochar process, and so on. So we solve the problem the CO, CO2, and stage 4. And there's another problem, the CNHM. CNHM is a new technology. For CNHM, we found we had tested different kind of the filter. Which one is the best one for the CNHM? CNHM means that if you input the stage 4, they have less reading. If you input the C2 and then C2. If you input the C3 and then reading is C3. So we found that 3.476 this filter is the best filter for the CNHM. This is our testing. You can see that they also have some cost sensitive to the stage 4 CNHM. So we had tested different kind of the input different kind of gas combination of the C1 and C3. We found the different kind of test that. So we should do some correction on the reading of the CNHM. So by this way, we solve the problem with the NDIR for CO, CO2, CH4, and CNHM. So we found this problem. And then the next one is the H2. H2 for the purified H2. Sorry.
I'm sorry, I missed what the correction. How do you establish the correction for
CNHM?
Your last slide, you mentioned that you had one, but what is it? How do you apply it?
CNHM means that firstly we should read the stage 4. After we know the stage 4, how much stage 4 have the cost sensitive to CNHM, then we can know. We can buy the regulation function to know the CNHM. I don't know whether or not I can explain to you.
Regression analysis.
Yeah. Because now is the input. There is the input. Here is the output for the reading, and then do the correction. Do you understand what I mean?
I think so.
Okay. So my bad language. Yeah. Okay. The last one problem is for the H2. H2 is very important. Very important. So the TCD technology for the H2 is a very simple technology. So you can buy H2 analyzer in the market. I think maybe $2,000 is enough there. But sometimes for gas file and the batch process, there's some problems there. Because, sorry?
Does CO have conductivity similar to oxygen or nitrogen?
CO?
Yeah.
Have?
Conductivity?
Yeah.
Conductivity. Is it similar?
To nitrogen?
Yeah.
Yes.
Okay.
So CO have no serious problem to H2.
Yeah.
The serious problem is the CH4 and the CO2. You know that CO2 here, 14. And the CH4 for 13. So CH4 will increase the H2. CO2 will decrease the H2. So if we vary the CO2 and the CH4, and the reading of the H2 is wrong. So we should do some compensation. Because we have NDIR, it's no problem for us. If we have no NDIR, just H2, how to know that? This is the reason we should combination of the NDIR and the TCD together. This reason I don't know whether or not I can explain clearly. So this is the problem of that. With the combination of the TCD, H2, and also 3 NDIR, and then we can do the correction of the H2 by this way. See, K0 maybe sometimes 0 because the CO have no serious effect on the H2, but the CO2 and the CH4 they have some problem to H2. So generally, see, I know as my imagination that CH4 just 5%. 5%. For example, 1%, 100%, we give 5% of the H2 reading. CO2 maybe 10%, just by different kind of the sensor technology. So NDIR and the TCD together, we can get the H2 correctly. So except the H2 sensor cannot get a good result testing of the two in produced gas, and also for biochar process. Okay, by this way, we know the 4 gas of the NDIR, and then the correct H2 and O2 is simple because you use the electrochemical detector. It's easy to do that. By this way, we can know the heating volume of the gas. Formally, is a difficult way to get this kind of parameters.